and welcome everybody. Thanks for joining us today. I'm Tessa and I'm going to be facilitating today's webinar. So on the webinar today, we have our Director of Sales Engineering, Branja Repchek, and the topic is what's new in CloverDX 5.7. So during this webinar, Branja is going to be talking us through the new features and upgrades in the latest 5.7 release. So a couple of housekeeping notes before we start. Please post your Q&As questions in the Q&A box and reserve the chat for any audio or technical issues. We don't want to miss any of your questions. Also, we're going to be sharing the recording and the slides after the webinar. So those will go out tomorrow via email, so keep an eye out for that. So with that, I'm going to hand over to Branja.
Thank you, Tessa. Again, welcome everyone to our webinar on which I'll introduce new features in CloverDX 5.7, which we released just 2 days ago, this Tuesday. As usually, a little bit of an overview of our release cycle. We release 4 releases every year, in general, approximately every quarter. And for each major release, like CloverDX 5.7, we release typically 1 or more bug fix releases. For example, for CloverDX 5.6, we released 2 smaller bug fix releases over the last 2 months approximately. With the introduction done, let's talk a little bit about what's new, kind of on the highlights, and then I'll talk about these and few more items in a little bit more detail. The first thing that we implemented in CloverDX 5.7 is quite large change in how Clover runs jobs internally. This is a huge performance improvement in some cases. We call it the job queue, and it's basically the ability for the server to queue the jobs that are submitted for execution and run them when the load on the server is a little bit lower, to kind of prevent the server from overloading, whether overloading on the CPU or running out of memory. Another thing that we've improved is the installation and upgrade experience. This will be very helpful for everyone who manages multiple servers, especially if you are running clusters, since the upgrade in the cluster has been made a lot more robust. And also when you are starting servers, for example, if you turn them on and turn them off, you are running containers or similar, you'll get a better log and overview of how the server is starting. As usually, we also continued improving our offerings in Amazon's and Azure clouds. We improved the way that we integrate with both platforms by offering encrypted disk storage so that you can secure data even better than you could before. We also have better integration with logging and for standalone database that's required for CloverDX to run. And finally, a security improvement for the APIs which require custom key stores and trust stores. Typically, this is needed for SOAP or REST APIs. So with this version of CloverDX, you can select custom key store and trust store for each of those so that you can have multiple different certificates for different APIs. As usually, we have a full list of everything that's been implemented in the release on our website. You can see the link at the bottom of the slide, but you can very easily get there from our homepage. And the full list of improvements is quite long, and I suggest that you have a look at that, especially if you are trying to upgrade from older versions so that you know which changes have been implemented in this release. Let's talk a little bit more about different features that I mentioned on a high level. The first one, which is the biggest change in Clover, is the job queue. This is something that impacted pretty much the very core of the server. It doesn't really affect designer that much because we do not expect people to running such huge loads on the designer, but on the server and especially on the cluster, this will make a difference, especially for those customers who run a huge number of jobs or jobs that require a lot of resources. What job queue does is that it changes internal scheduling algorithm on the server a little bit so that instead of running every job immediately as soon as it is submitted, the server monitors itself, whether it's the CPU or the memory load. On the cluster, this happens across all nodes, and it will run the jobs so that it doesn't get overloaded. It has different ways of measuring the data and different thresholds for different stages of the algorithm. If you are interested in that, I suggest you have a look into our documentation, which explains how this works quite nicely. I'll show you what it looks like on the actual server in a couple minutes, but you'll be able to see a few more numbers reported by the server when you, for example, query the statistics of the jobs and so on. This, as with everything else in Clover, can be enabled or disabled for different jobs. So it's very easy to change the way this works. And as expected, data services, which are the APIs in CloverDX, are not enqueued by default because you would expect them to run immediately as soon as someone hits the API. You'd want that executed. The second feature that I mentioned is the installation and upgrade experience. This is something that will make your life much easier, especially if you are trying to upgrade Clover or if you are running multiple instances, especially on a cluster. One of the things that you'll be able to notice is that when you are starting the server and try to log into the server UI before it is ready, you'll see a nice splash screen like this that will show you the progress bar, and you can click on the show details to see detailed log of what the server is doing and how the startup is going. So this is something that can help you debug issues as the server is starting. Maybe if it gets stuck somewhere, if it takes too long to do something, you will be able to see very easily which step in the startup process it is. Similarly, when you upgrade Clover, in many cases the upgrades also require upgrades of the database backend in Clover. This is accomplished by basically running a SQL script on top of the database. And with many of our customers, we saw that this was kind of an invisible step that they did not expect the database to be changed and did not make proper backups. So what the server does now is that it will pop up a window like this, asking you to back up your database before you perform the update. After you do your backup, you can hit proceed button and it will do the upgrade as before. We also made the whole process a bit more robust. So if you have a cluster and start multiple nodes at the same time, only one of the nodes will try to do the update instead of all the nodes competing for which one gets the log first. And so the nodes will talk to each other and figure it out among themselves. Another very interesting thing that we implemented was a change in our templates in AWS and Azure. This is not exclusive to Clover 5.7. You can also see the same on a bug fix release from 5.6. So 5.6.2 can also benefit from this because we have changed the layout of what is deployed on the cloud. Before, what we did was deploy CloverDX with an embedded Derby database, which, while it is useful and interesting, it's also not a recommended configuration for CloverDX. Instead of that, what we do now is that we create a separate server, depending on which cloud it is. For example, in AWS, we run AWS Linux. If you are in Azure, we run a different kind of Linux. Of course, everything runs on Tomcat in a single virtual machine, and we have a separate database. In both cases, it's a Postgre instance, either in Amazon's RDS or in Azure's database services. Yeah, so this is what gets created now. Of course, the networking and everything is set up in very similar way before that. Everything runs in your virtual private cloud within one region. In AWS, we also have to create a second availability zone, but by default, we do not populate it with anything. The goal is that if you need that kind of high availability, you can very easily create basically a clone of this database by yourself by modifying the CloudFormation scripts that are provided. By default, we don't do that because for evaluation, for example, which is the frequent use case for these templates, people usually don't want to pay for an extra database instance. Another thing that we've changed is that we integrated Clover much more tightly with the logging services provided by both AWS and as well as Azure. So you can configure the server very easily to submit logs to either CloudWatch or to Microsoft's monitoring service, and you can see the logs directly there from your web portal where you can access the logs for each platform. And as I mentioned before, we also allow you now to install everything on an encrypted storage. It's seamless. You don't have to do anything to configure that. Interesting feature that will help, especially those users who have APIs that require certificates to authenticate, is the ability to specify custom key stores and trust stores. Before this version of Clover, you were able to do that through various Java properties, and it was quite hard to do it properly because a number of properties influence the way this works, and it wasn't possible to, for example, pick different key store for different API calls. All that has changed because we have now implemented custom properties for HTTP connector and the same properties, the bottom part, for web service clients, which can do SOAP calls. So you can see that you can configure custom key store, password, alias, and custom trust store. Default behavior is exactly what was before, which you can see on the default values over here, that it's taken from the Java properties. So if you configure those and do not change anything in here, your code will behave exactly as it used to before. If you make changes in here, if you configure these values, they will override whatever is specified in the Java properties for given setting. Besides that, the way that the web services are called has not been changed. This is just about the authentication with the API. And as usually, there is a lot of smaller improvements. Some of them can affect the compatibility. So just a quick list. One of the things that we did is that we updated the Apache library that we use for working with Excel spreadsheets. This resulted in quite nice performance improvement and also significantly lower memory requirements. In some cases, the components will use about half of the memory compared to previous version. So especially if you are using larger Excel sheets, you will see the difference, especially if you are kind of on the limit of what your JVM allows you to do with regards to memory. We again have made several performance improvements in the product besides just a job queue that changes the way the server executes jobs. We also continue the implementation of streaming operations for various file systems. In this version, we added streaming operations for local file systems, meaning that when you have directories with lots of files, tens of, or hundreds of thousands of files, the list files component and any other component that requires listing of the directory content will be working much faster because the operation of querying the list of files from a directory is no longer blocking operation, but rather it works in chunks and submits the results in chunks to next stage of the process. So you can see quite nice performance improvements of this one. And since we've introduced variant in 5.6, we have made more improvements. They are not as large as introducing a whole new data type, but we continue making the integration of the variant type into CloverDX much tighter. For example, we added new container functions, new support for language constructs like for each or automatic upcasting and more. And finally, a few of the compatibility notes. If you are using Postgre, we have updated the driver. This was driven by us wanting to deploy everything in the cloud with a Postgre instance. So we are now using the latest driver. This should not cause any issues unless you had some specific reason for using the previous version that we had in the product. And with this, we now can run CloverDX Server on the latest version of PostgreSQL database 11.7. So it's now officially supported, even though our customers have been running on that kind of unofficially for a little while now. And one note about CTL, as we continue to make improvements around variant and a few other features of the language, we have noticed that there was kind of an issue with parsing floating point numbers. Before, we allowed syntax like this, so you could have typed something like 10 and period or decimal point, and with no fractional digits afterwards. That was considered a valid expression. It is not considered valid now because this interfered with our ability to call functions if you use dot notation. So if you need to do something like this, you have to type the 0 afterwards. That's the only difference. So this is not frequently used way of doing things. It's most likely a typo. in many cases where people just forget to type the fraction. So I do not expect a lot of you will have issues with this, just so that you know this is how you can fix it very easily. All right, and let's now have a look at Clover itself so that we can see some of the things live. What I have done is prepared an example where I try to load my server quite a bit so that I have some jobs submitted into the queue, and I will walk you through the user interface changes so that you know what to look for and how to figure out that your server is getting overloaded and is kind of entering a mode in which it has to defer executions. The first sign of something happening with the server is if you look into the monitoring screen of your server UI and see a graph that looks like this, you can see that we now have two different kinds of colors for jobs. The blue ones are jobs that are running, and the gray represents the jobs that have been enqueued. If I hover over a certain point in history, you can see that it says that enqueued jobs at this point, I had 8 and 44 running jobs. So this is something that can give you an overview of the load on your server. If you are loading the server too much where it can't keep up, you will see the jobs that are in the queue rising quite a lot, right? So if you are running, for example, a lot of smaller jobs, very quickly you might see a longer queue. This queue is on a per node basis. So if I switch to a different node, you can see that this is the same time interval, similar pattern, but this node was able to keep up and there were no jobs in the queue at any point in the history, right? So each node of the server behaves on its own, and the scheduler that works across the whole cluster and the load balancer know about the queues, and they will schedule the jobs in a way that the queue will not get longer unless you specifically force jobs to a specific node. So this is one of the things. You can very easily see the status at certain point in time also here, where you have the number of running jobs, and enqueued jobs is the new number over here. You will see the difference in the executions history as well. If I go and look at the job that I used to load everything there, and I just need to find which ones would be there, but you'll see new number over here. This is the submitted timestamp, and started timestamp might be different in cases where the job was waiting in queue for a while. Let's try to find one. You can see, for example, over here, that the job was submitted at this time and started 13 seconds later, so you can see that. This also impacts the APIs. As you all know, I'm sure that we have the APIs that give you access to this kind of information in Clover, and the APIs that reported started time always reported a non-null or a valid timestamp in there. This has now changed because job can be submitted to the server and not have a started time yet. So if you are relying on the APIs and expect the start time to always be there, you might need to update your code to deal with the fact that in some cases when the job waits for the queue, the start time will not be available until the job actually starts. Besides that, the execution of the jobs is not impacted in any way, and you don't have to change anything. As I mentioned, when you run data services, this is not visible anywhere in the UI, but data services by default do not get enqueued. That in turn also extends to data apps. So you have applications and services that people would expect to respond immediately. They do not get enqueued and are executed as soon as the request is received on the server. There are a few more changes in the execution properties. You can control the behavior of the job queue. For example, you might have a job that you do not want to be queuable. So you can set this setting, a property called queuable, to false. And that means that whenever you submit this job, it will be executed immediately, regardless of the queue length or the load on the server. This might be interesting, especially, for example, if you do something on a schedule and you have a tight SLA for when it has to start. The property is inherited by child jobs. So if you have a case like this, where I have a job flow and run a number of jobs underneath that, they will all inherit this property from the parent. That's everything about the job queue. Another thing I wanted to show is the cloud. This is the Azure portal, and you can see the new database over here. So when you create CloverDX in Azure, this is what it will look like. And many of the resources that we created before were the same. Now we have added a database, right? So this is how you'll see that. Similar thing happens in AWS, where you will see among your resources a separate database instance listed that the server uses for storing its data. This database is not meant to be for like business data. It's really just a database that stores the logs and settings of the server itself. Another thing I wanted to show a little bit is the improvements in the variant. One of the things that you can now do with variant is place it into a dictionary. So this wasn't possible before, but you can now create dictionary entries, and a new type appears in here called variant, and you will have to select whether the variant on the top level is a map or a list, but you will be able to assign pretty much anything afterwards. It works exactly as you would expect, so I can very easily create that variant and assign a map into it, or then override it with a list with different type entirely. So just what you want there. One word of caution: if you write a lot of data into the variant, it will not get stored into the database. Right? There is a limit on that because we don't want to make the database that keeps track of data and the APIs that return that value too large, because we've had use cases where the variant can easily be several megabytes. For example, if you pass something like a JSON document through the variant. Another improvement is, again, regarding variant, is the inclusion of new CTL functions that will allow you to work with it a little bit more naturally. For example, we now support a for each statement for a variant. You can see that I created a map that maps a key called key1, key2, and key3 to different values, and I can iterate through that. It iterates through the values, not through the keys, right? So the variable x will receive value of 1, then the whole variant or the whole subtree of the variant, and then a string. Similarly, we've added a lot of other functions that work with containers, and they now support variant, something like contains key or pushing into the list if it's stored as a variant, and many others. You'll be able to find this in the documentation. And of course, if you type in here, you'll see the overloads appearing in the list of functions in the content assist. And finally, an interesting feature, especially if you are using variant to work with JSON documents. If you imagine a simple JSON document where I have an object that might have a name and an ID, and you would expect the ID to be a long, but in some cases, it might actually be a smaller number that fits into an integer. The default behavior when parsing this is that this value gets parsed as a long, and this would get parsed as an integer, which if you write a function like this to query the ID, can cause issues, because you will get an exception that this value cannot be automatically cast into long because it's an integer. This has now been fixed, and we now support upcasting to types where you do not lose any precision. So this integer with this line would automatically be upcasted into a long value. Before this implementation, before 5.7, you would have to do something like this. And you can see that I'm trying to cast it into a long, and if that fails, I try to do the integer, and that then gets automatically upcast to a long. So we save you on some typing or some exception handling. This applies to multiple data types. Just have a look into our documentation if this is something that you need. And that's pretty much everything from my side. So I'll give it back to Tessa for Q&A.
Great, thank you. Yeah, we do have some questions that have come through, so I'm going to shoot them over. So first one, list files. Does that include reading from S3, or only local?
Yes, it does. The S3 performance update, the streaming from S3 was actually implemented in Clover 5.6. So if you have that, you already have that improvement. We have few other file systems left on the list where that will implement over time. But S3 and local files are both supported for streaming.
Great, thanks. So is the embedded Derby database still created and used by default?
No, it's not. So when you create something based on a template, if I go back a couple of slides, and what we had before, basically we didn't have a blue box in there at all. It only used the Derby in the virtual machine that was deployed in the cloud. Now that is not the case, and we do not create a database. It's simply all is stored in Postgre. Yeah, so you are not running two databases essentially, even though Derby is embedded. It's just the Postgre, and all configuration, everything, logs and everything else will go into that database. And
Thanks.
one note about that,
Yep,
maybe to add, this is not going to be a large database, right? Typically, unless you run millions of jobs, the database will be pretty small because it only keeps track of jobs that have been running and so on, right? So we do not store any huge data volumes there.
Great. I'm going to give everyone another minute or so to post any questions that they might have. Oh, saying that one has come through. For the enqueuing feature, can job priorities be pre-assigned to reduce the likelihood that a critical job will be delayed?
Depends on how you look at it. Basically, at this point, we have two levels of job priority. Either something is critical, in which case you can set it not to be enqueued and it will be running immediately, or something is not critical, in which case you can set it to be queuable and it might get queued. Yeah, so we might extend this to allow multiple priority levels and somehow pick from the jobs with higher priority, but at this point, we have just like a critical and non-critical jobs.
Branu, as I said, I'm going to give everyone just another minute or so to ask any questions. But whilst we're doing that, as Branu said, if you wanted to upgrade, the 5.7 release is out now and it's available and you can download it from your customer portal. I'm going to post a link in the chat now to the full release notes. So that's in the chat right now. But if you need help upgrading, we're happy to support you through that. I'm also going to share one more link. And that is a link where we can help you support. If you just fill in that form there, one of the team will jump on and help you. So yeah, I'm just going to give you another minute for questions. Right, I think that's pretty much it. No more questions for today. So again, thanks, Branu, and thanks everyone for joining. We hope to see you at our next webinar. Thank you.
Thank you everyone for joining. Have a great day. Bye.